Hey everyone, with you Elena Litvinova, and in this video we continue to resolve Leetcode tasks, and I found one new very interesting task at Leetcode with binary trees. Okay, let's try to go further and learn how to make one interesting Leetcode task on hard level. Okay, let's go. There is a task serialize and deserialize binary tree. So serialization is a process of converting a data structure or object into a sequence of bits so that it can be stored in a file or memory buffer or transmitted across a network connection, like to be reconstructed later in the same or another computer environment. In JavaScript there are two functions with serialization and deserialization. It's JSON stringify and JSON parse. Here I need to create something unique, something for binary tree. Design an algorithm to serialize and deserialize a binary tree. There is no restriction on how your serialization deserialization algorithm should work. You just need to ensure that a binary tree can be serialized to a string, and this string can be deserialized to the original tree structure. Clarification: the input-output format is the same as how Leetcode serialized a binary tree. You do not necessarily need to follow this format, so please be creative, come up with different approaches yourself. And let's go with examples. So for me, this task were very interesting because when I worked with binary trees at Leetcode, and for example, when I wanted just make console.log binary tree, I always found that it print like an array, but binary tree, it's not an array, it's quite deep object with left and right constructors, and it wasn't very comfortable because for me, for example, I needed to understand how this tree should look like. However, in Leetcode, when we look on test, we can see the picture of binary tree, so that's okay. And continue. And I was interested in this task because we print an array, and I was thinking, oh wow, how they did it, like binary tree and they just convert it in array. Seriously, is it possible to make of? And yes, it's possible. And I found this task and I was thinking, okay, it's really cool to try to resolve, and let's try do that. Okay, we have serialize and deserialize, and I want to serialize in array and deserialize from the array. For me, it's just interesting. How we will do that? So if we look at input and how here this array looks like, you might be very fast to understand if you're looking for my video, if you looked my videos before about binary trees, about different traversals, depth first search and breadth first search. You will find that this is breadth first search. We go through the levels, so 1, 2, 3, 4, 5. And how you see how it looks like here. We have 1, after it 2, 3. We have left and right. After it we have null, and it means null is left is null, right is null. But here it's not null, right? So it's everything is fine. And I was thinking that yes, this is breadth first search, and we just need to save these nulls. And when we will deserialize it, we just will think, we also will use breadth first search, so to go with the same approach. And if we meet null, it will just for us mean that this direction is closed for us. We need to go to the second one. And let's do that. Basically, it's not seems very difficult, however, it's hard level. First of all, if we don't have root, we just need to return just array, empty array. And what's next? We should to have a queue, and we should to have queue, and in queue we put root, and here we have result, and result we have root val. After it while queue length, and we say here, okay, we say const current node, we say queue shift, so we become from the beginning. first in, first out. Because of it, it is queue. And after it, if we have current node left, else we need to push in queue, push this node, and we need to push in the result, we need to push left val, right? And here we should to push, if for example there is no left, we push in result, push null. And the same with the right node. So we have right. And also push right. And here we return result, like that. And it should work. We can console.log result, and we just can run. And it doesn't work because we hadn't written another function yet. However, how we see, it looks quite similar. So we have 1, 2, 3, null, null, 4, 5. But at the end, we have a lot of nulls. I didn't know how to resolve it like without these nulls. I have just only suggestion how to remove all not needed nulls after the algorithm. Somewhere here we just go from the bottom of the array and just remove all needed nulls. However, how to make it here, I didn't know exactly, because, for example, if we have quite complicated tree, we have here null, 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 right? But if we have null, 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 and last one will be a number, so we anyway should somehow recognize that will it be somewhere null or not. So we anyway need to go through all possible edges, and we return this array. However, if we look on the beginning, 1, 2, 3, null, null, 4, 5, so it's absolutely the same. We did it right. Okay, we just can, for example, let e is equal result length, I length minus 1, I more or equals 0, I minus minus, and we just need to check if a result of I is equal null, we just say result pop, and that's it. Else we just break. Console log result, run. In that case, we have exactly the same array as we had here, so yeah, easily. And we can make it as a string, so it's quite easy, quite interesting. And with this additional loop, we just can save space. If, for example, we send this arrays through network or in another computer, and as less it is, as faster we can send our data, right? Okay, go forward. Deserialization. So we have data, which is array, and we need to return back on tree format. First of all, we again need data, length. If it's not, we just should return null. There is nothing. Also for tree, we should create additional function, which will be here. 3 node val, this val, so we need to create nodes, and we need this function. And after it, we again need const q, const tree first of all. Here we should to use this constructor tree node. Here we put data of 0, and after it we have q, and we say tree. And after it, we will use this queue. We also again will use breadth first search. You can use depth first search, but I usually prefer breadth first search because it works faster, and we never reach maximum stack call for recursion. So it depends on how you start your code. However, yeah, it's better how I think. And anyway, it's also okay to use depth first search approach, and you can try if you want. Okay, and how we will resolve it next? So we have an array, we have a queue, and we have data. And basically we save this data with breadth first search approach. It means that we need just recover our array and create again the tree. So how we created here our array. So first is root, this is left, this is right, and we go like left, right, left, right, left, right. For that, let's create a for. And we need to recover this data the same way. We start from 1 because we already put here first, we created a tree root. So we started from the second element, I less than data length, I plus plus. Inside of it, what should we do? If we already saved a tree, and in the queue we will save the path to the nodes which we go inside. So we have tree and we just have link to this root in our queue, and we will need to push in this queue elements which is next links to our inside elements. So firstly we put link on the root of our tree, after it we put link here, and because objects in JavaScript passed by links, at the end we will have it's just the link on the root, and inside we will just create our tree. Okay, and what we should to say? Const current node, we say q shift. And after it, we check if current node left, then we go here. I put here question marks, just if, for example, somehow here will be null. It shouldn't be because we will not push. It shouldn't be. Okay. And right as well, if not right. If we have data of I, not equal than null, we go here and say q push. First of all, we need create current node left. Current node left is equal the same of I, and we should to say push left. So we just push in the queue the link inside of node which we just created. And at the end we just need to return this tree. And here we need to do the same. If data not equal null, we just only here to use right. And because I check here and left and right, I need to understand right, left it or right. I should also to make I plus plus and make another condition. If I more or equal data length, just break. And after it return tree. Run. Oh, it works. Submit. If you like my content and the videos which I create here quite a lot of different things around web programming. You can subscribe on my channel, press bell icon, and see you in next videos. With you, Elena Litvinova. Bye bye.